Okay, I'm going to do problem number 1. This involves vectors. We have a plane that has an airspeed of 700 miles per hour. It's headed north 40 degrees east. The wind is blowing north 15 degrees west at 80 miles per hour. Now when you take the wind and the plane and consider those two situations together, you have a resulting direction and ground speed. So what we want to do is we want to kind of draw a picture of both vectors and get a visual of what's happening. So the plane has an airspeed of 700 miles per hour, headed north 40 degrees east. So this length is going to represent 700 for the magnitude. Now 40 degrees east from north means that our direction angle, the one that we put into the calculator, is going to be 50 degrees. Because the one in the calculator is always going to start on the positive x-axis and then rotate either clockwise or counterclockwise. So when we have our plane vector, we have 700 for the magnitude, and then we have the cosine of 50 degrees, comma sine of 50 degrees to show the direction of that vector. Now it encounters a wind that's blowing at 80 miles per hour in the direction of north 15 degrees west. So north 15 degrees west would be something that looks similar to that. And then of course 15 degrees is with the vertical. So the calculator again is going to take 90 plus 15, which would be 105. So our wind vector, its magnitude is 80 and its direction is 105 degrees. And when you add the plane and the wind together, we're going to get the result. And the result, when we put this into our calculator, we're going to put 700 times the cosine of 50 degrees plus 80 times the cosine of 105 degrees, which will give us a horizontal component of 429.246. The vertical component is 700 times the sine of 50 degrees plus 80 times the sine of 105 degrees, which is going to give us a vertical component of 613.505. Now we're going to store these two values as A and B so that we can be as exact as possible. When we try to find that resultant vector visually, we're going to get something that looks like this green vector. Now this green vector is a little bit longer than the original red vector. So I'm thinking that the ground speed, which is your magnitude, is going to be greater than 700 miles per hour. That's my thought. The direction is going to be north, definitely east, but it's not going to be as much as 40 degrees. It's going to be a little bit less than 40 degrees. How we find that direction is by putting the ratio in. Now what I'm going to do is I'm going to show you this one time here. Here's my assumed resultant vector in green. Remember, I think that this angle right here is less than 40 degrees. When I find that angle and I make a right triangle, I have a horizontal component of about 429. I have a vertical component of about 613. I'm going to do the inverse tangent of 429 divided by 613. Well, that's the inverse tangent of A over B. So when I put that into my calculator, I am indeed going to get an angle less than 40 degrees. It is 34.979 degrees. So we're going north, which would be up, north, and then we're rotating towards the east, 34.979 degrees. Our ground speed, again, square root of a squared plus b squared. If you put that into your calculator, we get, I thought it was going to be a little bit more than 700 miles per hour, and it is indeed 748.759 miles per hour. Now, if I look at the answer key, 749.759 miles per hour and 34.979 degrees east. North, 34.979 degrees east is indeed what the answer key says. So what I would recommend is maybe listening to this video again, using your calculator, make sure that you're getting the answer that I'm getting. Put all of this into the calculator. Make sure that you get the answer that I got. And then when you feel confident with that, you'll be able to do number 2, because number 2 is just like number 1. Number 2 is just like number 1. All the evens practice the preceding odd problem. So give that a shot, and I'm sure we'll be feeling confident and growing our intelligence